the suite that we are leading is the simulation optimization suite that is part of the DMAT project. In this project, we are developing digital technologies for modeling, simulating, and optimizing. And we want to apply our toolkit to every stage of the materials value chains, considering the material value chains by design, processing, and manufacturing. We are developing three toolkits. DMAT, Material Mechanical Property Simulator, Material Process Simulator, and Digital Twin for Process Control. The first toolkit is Material Mechanical Property Simulator. This is a numerical toolkit focused on materials and components. We are looking for links between the material properties, the fraction, the material parameters, and the mechanical performance, or the compound performance. The second toolkit is Material Process Simulator. We focus on process modeling, and we are looking for a link between process variable a performance metric of our product. And the last toolkit probably is the most disruptive element of this toolkit is digital twin for process control. Digital twin can be a digital twin of a product or digital twin of a process. We are developing digital twin for a process. And this is a special element that consists in two parts. The real process with a sensor, and the virtual part is a virtual model. We have a sensor that transfers data to our model, and the model that transfers information to the sensor and to the control. So with these three toolkits are the basic element of our suite. The three toolkits that we are developing can be used alone or can be used integrated in a group. We can, for example, we can optimize a material, the performance of a material, looking for the optimum composition only with Material Mechanical Process Simulator, or we can use our Material Mechanical Process Simulator as input of the mechanical of the Material Process Simulator, that is the second toolkit, in combining both. We can apply, for example, we can apply first to establish a relationship between the variables and the material parameters with the second toolkit. After that, we can use the first. And also with the third toolkit, that is digital twin, and the virtual model can be data-driven, that is based on data, or physical. If we are applying physical model, we can use the first two toolkit inside the digital twin. So we can integrate the three elements in an hierarchical approach. And the relation with other two suites is also very strong. With suite one, we have a relation with with toolkit one, the data management suite, CMDB. Due to all data-driven models are based in data, in the database managed with the first suite. And with suite 2, we have more connection with materials modeler and material designer. With material modelers, we are setting some elements due to MMS use atomistic simulation. And also material modelers use this kind of simulation. I mean that, for example, with material model, we can predict the microstructure of a product, and with material mechanical property simulation, we can predict the properties. So we can use in a multi-scale approach, we can use both toolkits. With material designer also, we share finite element modeling. With finite element modeling, is one stronger part of our two toolkits. Also with material modeler, So the same problem can be aborded with different approaches, with different ideas, depending of the customer, depending of the objective of the customer. We can apply these three elements: some toolkit of the Suite 2 or some toolkit of the Suite 3. I can distinguish between optimization, simulation, and control. Speaking first about optimization, if we want to optimize a product, or if we want to optimize a material, we have experience, we have data-driven modeling, and we have physical models. Our competitors are physical models that can be done with commercial code, commercial finite element code, for example, Abacus, ANSYS, Nastran, COMSOL, with very high license fees. Could be freeware finite element software, or could be also some special toolkit developed from the numerical code. The advantages that offer DMAT toolkits against the traditional solution is that DMAT toolkit are based in open source software. This is a very important advantage against commercial solution due to the license fees is very high. This kind of solution has a very high licenses overall for SMEs. Overall for SMEs that cannot afford in innovative activities due to this limitation. Speaking about freeware software, for example, Calculus, Codeaster, it's a very strong solution, but require a deep knowledge of this toolkit. There are some problems, for example, some compiling problems, some for installation, for example, you need a specific version of the operative system, you need a specific version of libraries, and it's not very easy to reach this type of knowledge. DMAT toolkit are personalized elements to avoid this problem. Also, an important element is that in DMAT we are combining physical modeling with data-driven with artificial intelligence. And this combination of all these elements, of all these possibilities that exist now overall with the interaction of artificial intelligence with machine learning is very difficult to find a tool, to find an element that can integrate all this part. And the other part of the answer is relative to digital twin. Digital twin deals with control, with monitoring of activities, industrial activities. This task has been done traditionally by experience with sensors. Digital twin is a disruptive technology. Digital twin is a new methodology that is introducing it in industry during these days. One problem of digital twin is that it does not exist open source element. All element that exists up to now is necessary to pay a fee. And in some sense, we want to advance, or we want to solve this drawback overall for SMEs, overall for SME companies. Our solution has a very huge market due to we are dealing with optimization. We are dealing with monitoring. So we can apply our solution in manufacturing, in a lot of sectors, for example, in automotive, aerospace, machinery, electronics, sectors where the optimization is a complex process. We can apply our product. But for example, in other sectors, in infrastructure management, it's possible to apply this type of solution. Digital twin is for industrial process, but digital twin could be used to manage infrastructures. The digital twin of a pipe, digital twin of a highway is an important element and has sense. We can apply our toolkit by engineering firms, by other technology and software companies. And speaking about the SMEs, we offer an important advantage to introduce innovation in SMEs. Overall, dealing with reducing costs, our toolkit is a means for reducing costs during innovation. Not only for SMEs, although a big company has enough resources to avoid innovation or research and development, one of the limitation, one of the bottleneck for a big company is the needs of licensing. The license is limited. The number of licenses is a finite number, so it's important to have this kind of toolkits to surround the problem. Research Institute or other consulting advisory service can also use our toolkit due to our vision, our hierarchical application of our friendly interface could be very useful for a huge field of companies.